You can see on my smartwatches. I think they're very, very powerful for, tracking people's health, better profile people's health, and then hopefully catch disease early and better, again, manage their health.
Oh, wow, this changes everything for personalized medicine. What emerging technology in your lab right now makes you feel, oh wow, this changes everything for personalized medicine, and how might it redefine the clinical paradigms we take for granted today?
Oh, good question. So I think what we've been able to do over the years is invent a lot of basic technologies, RNA-seq, paired-end sequencing, which lets us map out the genome and find structural variants, things like that, protein microarrays. So most of these were basic science technologies, once again, to help us understand how things work. But I think what we've been trying to do more recently is applying all these things to try and better manage human health. So for example, genome sequencing was a concept before, but now you can actually sequence people's genome and at some level predict their disease list. We have a long ways to go, but we're getting started on that. Certainly things like BRCA mutations, single gene mutations are pretty good. We're trying to bring in other technologies as well. Proteomics, metabolomics in particular, we think is quite valuable for profiling people's health. We're doing a lot with wearables these days and smartwatches. You can see on my smartwatches. I think they're very, very powerful for tracking people's health. And so we're trying to do just that, bring in big data types to better profile people's health and then hopefully catch disease early and better, again, manage their health.
Could this technology replace traditional lab tests for specific applications? And what biological validation challenges should we solve before we consider them as real diagnostic tools?
Yeah, I think they will replace some of the things we measure in a physician's office now. So for example, resting heart rate is actually rather poor in a doctor's office because people get very nervous and their heart rate goes up. But if you pull their resting heart rate from first thing in the morning, that's actually a pretty consistent measurement of someone's health. Meaning if they are having physical issues, say they've got a viral infection or maybe they have mental health stress, their heart rate will be elevated and you can grab that right from a smartwatch. So I think we're in the research phase right now, but it's becoming very, very clear that these are powerful for the reasons you just said. They track your health continuously and so you can see shifts. What do we need to do to get them implemented? I think we need to validate them, so show the watches themselves are pretty consistent. People are doing that. There's a few FDA-approved devices. And then once we get the devices validated, show their applications are validated. So one of the things we've been able to do, you may know, is we've been able to see when people are first getting ill from a respiratory viral infection like COVID, because their heart rate jumps up. It's a very easy thing to detect. You can detect it before symptoms come, because people's heart rate goes up in advance of symptoms. So it's a very, very sensitive assay for human health. So I'm very optimistic these will be very, very powerful as health monitoring devices in the future.